So we have discussed the basic intuition of the skill bias technological change model and the most important definitions, we now move on to discuss the full model. And to this end, here we have a sketch of this framework to see how the building blocks actually interact with each other, where the different prices and wages are determined for the different sectors and how the dynamics are. So what we have in general is the households that consume the goods that are produced by the firms, where we have the firm sector on the right-hand side, and they pay the price PY for these goods that they consume. At the same time, they supply their labor on the labor market, and there are high-skilled households and low-skilled households, where the high-skilled earn a wage WH and the low-skilled the wage WL. And they also save, and for their savings, they get the return on investment or the interest rate here R. So that's what the households supply, and that's what the households demand actually. And on the right-hand side, we have the firms that supply the goods that the households want to consume, and they get the income of that. And they themselves produce with the final goods with intermediate goods. And there are two types of intermediate goods. Intermediate goods produced with high-skilled workers and intermediate goods produced with low-skilled workers. And both are needed to assemble the final good. The households basically that supply their labor on the market, they work then in the intermediate goods sector, the high-skilled workers in the high-skilled goods sector, and the low-skilled workers in the low-skilled goods sector, basically. Or I refer here to it for simplicity as the high-skilled intensive intermediate goods sector and the high-skilled, low-skilled intensive intermediate goods sector, although they only use high-skilled and low-skilled workers in this framework. Then that's basically also where the wages are earned of the households. Now, the intermediate goods sector, the high-skilled intensive intermediate goods sector, uses machines that are suited for high-skilled workers, and they are produced in the machine sector here with using capital from the households that the households saved as an input, and what's paid for the capital is the rate of return, basically. And we have a low-skilled intensive machine sector that supplies the machines for the low-skilled intensive intermediate goods sector, and they get the price for their machines here. And then in order to be able to produce these firms have to purchase a blueprint from the research and development sector, similar to the research and development based growth literature. So we have imperfect competition here. These firms earn profits, and the profits are used to cover for the fixed cost of the patent that they have to buy in the first place. So there are two types of R&D firms: the ones that produce the patents for the machines that are suited to the high-skilled workers, and the one that produces the patents for the machines that are used by the low-skilled workers in the low-skilled intensive intermediate goods sector. And then we have the standard market clearing price mechanism setting in here. So we will have that a price vector will establish that determines all the prices, the wages of high-skilled workers versus the wages of low-skilled workers, prices for the different goods, the interest rate, and so on and so forth. And the market basically will then ensure that this is the market clearing price vector for which the supplied quantities and the demanded quantities are equal to each other. And if there is some comparative static change, then we will see that there is an endogenous adjustment of this vector and an endogenous adjustment of the corresponding quantities. Now, the resource constraint has to hold that tells us that consumption plus investment in machines plus investment in research and development has to be not larger than overall output Y. So that's the resource constraint in the economy. And now what we will do next is we will look at the different building blocks and solve for optimal behavior of the different firms, of the households, and so on. And then we will put the building blocks together to solve for the general equilibrium of the model, and then analyze what happens if we change exogenously the ratio of high-skilled to low-skilled workers. And as a spoiler, we will see that this induces technological progress that is bias. So if the number of high-skilled workers relative to low-skilled workers increases, then it induces research and development that is biased towards the high-skilled workers. And under certain circumstances, this can be so high that the equilibrium price vector contains entries for wages of high-skilled workers and wages of low-skilled workers, and the skill premium, which can be derived from that, that will increase in response to the increase of high-skilled versus low-skilled workers in the first place. The first thing we look at is the production function in the final goods sector. So here the aggregate output is produced that is used so by the households to consume, or by firms to invest in machines, or it can also be used as an investment in research and development. Now this is produced with the two intermediate inputs, YL, which is produced by low-skilled workers, and YH, which is produced by high-skilled workers. The shares are given by gamma L, so similar to the production function that says production function that we had already seen in the first part of the lecture. And we have an elasticity of substitution that is epsilon between the two inputs in final output production. So epsilon is between 0 and infinity, basically. If it's infinity, the two intermediate goods are perfect substitutes in production of the final good. If epsilon is equal to 0, then they are perfect complements. And for epsilon equal to 1, it would kind of collapse to the Cobb-Douglas production function. The resource constraint I've already mentioned, so this final output can be used either for consumption or for investment in machines or for investment in research and development. Next, we have the households. The households have a standard isoelastic utility function, constant relative risk aversion, where the risk aversion is again determined by theta, and 1 over theta is the elasticity of intertemporal substitution, as we've already seen in many of the lectures here. Rho is impatience again, so households are more impatient if rho is higher, so that's the time preference rate, and we take the integral from time 0 to infinity because it's assumed that there is a dynastic household in this sense, or an infinitely lived representative household. Now we know already that dynamic optimization would imply that the consumption Euler equation looks as it looks here. We also have seen this already in many of the courses, but just to repeat it here for those who only watch this video, we have consumption growth, optimal consumption expenditure growth on the left-hand side. So that's the time derivative of consumption divided by the level of consumption. That's consumption growth. It's the difference between the interest rate and the time preference rate, because if the interest rate is high and I'm rather patient, then this would be positive, meaning that I would want to consume more in the future and less today. I want to save because the interest rate compensates me for my impatience, overcompensates me for my impatience. So I reduce consumption today and increase consumption in the future, and that is nothing else than having a steeper consumption growth path. So if the difference here is larger and positive, then consumption growth will be steeper. And the elasticity of intertemporal substitution, 1 over theta, mediates the process basically. So for a given difference in the interest rate and the time preference rate, a higher elasticity of intertemporal substitution would mean that ceteris paribus households would be willing even to shift more consumption over time. So a given change in the gap between the interest rate and the time preference rate would then induce a larger response of the savings behavior, and therefore a larger response of the slope of the consumption expenditure growth path. Well, and then we have that the transversality condition has to hold, and in this case the transversality condition basically is that the value of the total stocks in the economy, and the value of the stocks is equal to the value of the stocks of firms that produce low-skilled suited machines and firms that produce machines suited to high-skilled workers, because that's where we have monopolistic competition. So these firms have a value, and the value is equal to the patent that they have to buy from the research and development sector, because there is free entry. So if the value of these firms were basically lower than the patent, they wouldn't buy the patent in the first place, so there would be market exit. And if it's higher, then there would be market entry, and all would drive the price down basically to this value of the patent. So the total value of all these stocks, which is the value of a firm that produces low-skilled suited machines, the value of the firms that produce machines suited to high-skilled workers, times the number of these firms, discounted basically to today. So by the discount factor, which is the interest rate, and then the limit as time goes to infinity has to be equal to zero. And that's again the standard interpretation of the transversality condition. So if this was positive, it would mean that households would leave assets on the table as the economy goes to an end, and that would not be optimal. So they could have increased lifetime utility by consuming more. And if it was negative, then actually households would run into debt as the economy goes to infinity. So they would accumulate ever more debt and faster than this discounting decreases in the future. And that would actually mean that the financial markets allow them to run into ever more debt. And that's ruled out by the no Ponzi game condition. So the only viable solution would then be the one that fulfills the transversality condition with equality. Next, we have the intermediate goods sector that produces the two intermediate goods needed for producing the final good in the end. Now, what do we have here? We have Cobb-Douglas production functions, where these intermediate goods are produced with the corresponding machines. So the intermediate good that uses low-skilled workers produces with the machines coming out of the sector that produces the machines for the low-skilled workers, where we take the integral from 0 up to NL, because that's the range of all the machines that are suited to low-skilled workers, with the upper bound basically NL being the latest developed blueprint for machines that are suited for low-skilled workers to produce. And then we have the low-skilled workers themselves, and the output elasticity basically in this sector is better for low-skilled workers. So if LT increases, beta measures by how much YLT increases. And a similar production function holds true for the intermediate good that is produced with high-skilled workers, just that LT and HD change places here, and we have the machines that are suited to high-skilled workers here, and the range over all the machines goes from 0 to NH, because NH is the latest blueprint that had been developed for the machines that are suited to the high-skilled workers. The axes here are the quantities of the different machines used in production. And one crucial assumption in the model is that machines depreciate after use, so that we can very much simplify the dynamics here. So there is depreciation after use, so we don't have to sketch out all the dynamics of the capital stock in the model. Yeah, and 1 over 1 minus beta, that's just a normalization here that has no consequences basically for the qualitative results in the end, but it makes the calculations simpler, because if we take later on the derivatives with respect to XL and XH, we see that 1 over beta comes down from the exponent, and that would then cancel out with 1 over 1 minus beta from here. Next, the machines are produced by the monopolists in the machine producing sector, where it's assumed that they have a perpetual patent over the particular machine variety that they produce. Therefore, they can charge prices PLX for the particular variety new, and PHX for those who produce the machines that are suited for high-skilled workers for their machines, and these prices will be above the marginal cost. So these firms has monopolistic power basically. The marginal cost of producing a machine is by assumption given by 1 minus beta here in terms of the final good. And this is again just a normalization because then many terms cancel out, and thus notational clutter is avoided by defining that in this way. Then we can write down the total resources that are devoted to machine production, which is then the marginal cost of producing a machine here, 1 minus beta, multiplied by the total amount of machines produced in the economy, which is the machines of each variety, integrated from 0 to NL for the machines suited to low-skilled workers, plus the same for the machines suited to high-skilled workers. Then we have all the machines, and we have the marginal cost of producing each machine in terms of resources or capital, if you will. and that leads to the overall amount of resources or capital that we have to invest into machine production, given this production of machines, and that's equal to xt that we already know from the resource constraint. Now, the last sector that still needs to be described is the innovation sector. And here, Acemoglu, in the baseline version of the model in his book, follows a lab equipment specification, which means that in contrast to the R&D-based growth literature that we've seen before, where labor is used as the main input in research and development, so scientists, here it is final output that is invested, and that can be interpreted as being equal to lab equipment. Then there are two innovation possibilities, frontiers, for the patents that are produced in the sector that produces the patents for the machines used by low-skilled workers, and the production function for the innovation sector that produces the patents for the machines that are used by the high-skilled workers, basically. So this is the time derivative of the stock of patents in the two sectors, which is newly produced patents. So it's the production functions in these two sectors. Now, output is produced, as I said, by investing final output. ZL is final output invested in the patents for machines for low-skilled workers, and ZH is final output invested for patents production for the machines used by high-skilled workers. And eta L and eta H are the productivities of output in these two sectors in producing the new technologies or the new blueprints, basically. And then total R&D expenditures is the sum of R&D expenditures on patents for the machines used by low-skilled workers, and ZH as the amount of resources used in the production of patents for the machines used by high-skilled workers. Now we can compute the market value of a monopolist. That is, as in the standard R&D-based growth literature, the discounted stream of operating profits of the machine producer, which is also equivalent to the price of the patent. The reason for that is that the R&D sector can extract all these operating profits from the machine producers because of free entry in machine production, as I've described before. So if it charges a lower price, there would always be a firm willing to outbid such a lower price, and if the price would be higher, then we would have exit of firms. So here we have the operating profits at each instant of such an intermediate goods producer, and then the discount rate is the interest rate. So if we discount this up to today, t, then we have to take the integral from t to infinity, and that would be the value of such a firm. The instantaneous profits in turn are given by the price that a producer of variety nu can charge for its machine, multiplied by the output of the machine variety. So there we get total revenue, and from that we have to subtract the cost of production, which is capital input or resource input, multiplied with the marginal cost in terms of resources needed to produce the machines. And that holds for both sectors. So irrespective of we have in this index F, whether we have the low-skilled here or the high-skilled. So irrespective of whether we refer to the machines produced for low-skilled workers or for high-skilled workers. And then we can apply the familiar Leibniz rule again to get the no arbitrage relationship for rational investors. That would tell us that there are two savings vehicles in the economy. Either I get the interest rate RT on an investment of the size VF, or I get, so that's what I get when I invest in an interest-bearing savings vehicle, basically. And on the right-hand side, we have the return that I would get when I invest in the shares of a machine producer. So if I buy the machine producer, or which is equivalent in this case, if I buy the corresponding patent. What I get then is operating profits at each point in time, plus potential valuation gains of the share of the firm or of the patent itself, because if I sell it at a higher price in the future, then I earn a valuation gain. And these two have to be equal to each other, because otherwise a rational investor would only invest in the saving vehicle that yields the higher rate of return. Now some comments before we solve the model. The price of the final good is normalized to 1, so this is the numeraire. And this is basically equivalent to a setting in which we have an ideal price index of the two intermediates. It looks like this here, which is normalized to 1 basically, where PL and PH are the price indices of the two intermediates, YL and YH. The intertemporal prices are given by the interest rates RT at each point in time T, and the factor prices for L, interpreted as low-skilled workers, and H as high-skilled workers, would be given as the wages WL for low-skilled workers and WH for high-skilled workers.